polarization. Transverse waves, for example light and other forms of electromagnetic waves, can have, and other transverse waves too, mechanical ones as well, can have many different planes of oscillation at right angles to the direction of energy transfer. So there's the direction of energy transfer. Over here we've got these different arrows indicating different ways, different angles at which the transverse wave could be oscillating. All right, so if there are lots of different things present, we say that the light is unpolarized. Underline that word there. In contrast, if we polarize the light, we now see that we only have one plane of oscillation present there. And so I'm going to quote you the definition from the dictionary here, where it says that polarization is where the oscillations in a wave are confined to one direction only, this is the sort of definition that you would write in an exam type situation, comma, the direction being at right angles to the direction I'm going to use a word here, of propagation of the wave, of propagation of the wave. The word propagation is just a fancy word, just means the direction of travel of the wave. So this light in this diagram here has now been, or this wave has been polarized. There is only one plane or direction of vibration present. If we have a look at that in the situation of light then, over on the left hand side of this diagram here we have unpolarized light traveling along from left to right. We then place a sheet of Polaroid, or what's known as a polarizer. So unpolarized light can be polarized by passing it through a Polaroid sheet. Alright, so this light here has been passed through a Polaroid sheet, and what the Polaroid sheet or the polarizer has done is it has polarized the light such that in this particular instance only vertically polarized light has been able to pass through the sheet. So we've now polarized it. So let's have a look at a couple of situations there. Once we've polarized the light, here, if we were to have a second Polaroid sheet, which has been called the analyzer, you don't really need to know that name, but if we have a second Polaroid sheet where the direction of this sheet here and the direction of this sheet here is the same, then no, there is no change. The light continues to be passed through the second sheet. So we've still got our vertically polarized light. In the bottom diagram though, this time we've got one Polaroid sheet this way and the other Polaroid sheet at 90 degrees to that. We can say that the Polaroids are crossed. So when the two Polaroid sheets are crossed, then the first sheet cuts out the vertical. Sorry, I get it right. The first sheet cuts out the horizontal and lets through the vertical, and the second sheet cuts out the vertical and lets through the horizontal. But because there is no horizontal, nothing gets through. And so that's when you've got the two Polaroid sheets turned around such that when you look through them, you see nothing. Now, in terms of this diagram, you've got these basic diagrams here. In terms of your notes, what you can do is you can just print these off and stick them in your notes. You don't need to add any more than what's on the diagrams themselves. So the word crossed isn't really needed. Just simply put those diagrams in your notes. All right, and we talked about this in class. Light reflected from water, buildings, snow, etc. is polarized on reflection. All right, so the light that we see coming off these surfaces already is polarized. So if we were to look through some sunglasses where the Polaroid or the polarizing sheet is the right angle, then it would be able to cut out that polarized light. And so we're on the left-hand side here. You can't see very much underneath the surface of the water. On the right-hand side, hey presto, well, that's what we're after there under the water. So we're able to see more clearly, and it cuts out that glare that also, you know, is sort of makes your eyes feel tired and strains your eyes. There's another example there. Now, what they actually do with this, there's a hook shape, but engineers, in trying to sort of analyze the stresses on that hook, actually would model that hook out of perspex. They would shine a light through the perspex, and by analyzing the polarized light and looking at the different colors, you can identify which parts are experiencing more stress than other parts. And finally, the transverse nature of light, the fact that light as an example, the fact that light as an example of an electromagnetic wave can be polarized then provides evidence for the transverse nature of electromagnetic waves. Whereas in contrast, the fact that sound, which is is longitudinal nature, in contrast, sound, which is longitudinal in nature, cannot be polarized. You cannot polarize a longitudinal wave.